right?
Give it a moment.
Just give me the heads up when do I start.
I think I need to wait. I think I need to push the button.
Yes.
Okay, it's on actually.
All right, okay, hello everybody. I'm Romans Karpelcevs, and I'm gonna talk about migrating to Kubernetes, but from the developer's perspective. And before I start, I'd like to ask, who's here doing infra stuff? Who's more of a software developer doing like product development? You're doing both, right? Who's not from tech at all?
And the Scrum Master?
So you're the Scrum Master? No? All right, okay, I just wanted to understand approximately the crowd. So like I said, I'm Romans, I'm from Latvia. I moved here to work first at Pipedrive as a mobile engineer, and in Latvia I did most of my work as an embedded or software engineer doing mobile apps. But for the past year, I've been the head of engineering at Outfunnel, and in the past year, we did the migration from, I'm gonna show from where to Kubernetes, and I participated in that mostly as a developer or as a DevOps person. And kind of the whole idea of this talk is to show how it looked like, or what were the most interesting things or the pitfalls, or how we had to fix them. Kind of the plan for the talk would be to show kind of the journey, what did we start with, where we went on, what were the problems initially and later in the game. I want to talk what didn't work out that well, obviously, and I'll be open for any questions that you might have. And please let me know if I'm not standing in the camera center. So at first, where do we start? Early 22, we had a bunch of EC2 instances, I don't know, maybe 20, 30. Everything was manually provisioned. We didn't even have Ansible. We, every service was running as a systemd service. The deployments happened in a way that we built tarballs, uploaded them in a loop, or maybe not even in a loop, to the server, unpacked it, and there was a deploy script that restarted the service. No Docker, no nothing. Any change in configuration required SSH access. You didn't really know until something broke down, until there was a drop in one of the Prometheus charts or something, or customers complained that something is not really working. It was really messy, but even bigger than kind of this thing, which was a little bit invisibly handled for the customers, were that we couldn't scale anything. One of the things that Outfunnel does is emails sending, and you can set up a campaign and target particular customers. And for example, for the Black Friday, if you knew that your load is going to be higher, you had to spend some extra time provisioning an instance, and all of that was done manually. And if there's suddenly a customer that was doing more stuff than usually, again, a service hit the CPU limit, and any changes in the instance size or whatnot was done manually and by an infrastructure person. And the decision was to switch to containers, and we chose Kubernetes over ECS, mostly because Lauri joined us and he knew Kubernetes more than ECS. Our kind of first steps was to set up the cluster, to do the networking and some VPC things, which we kind of failed a little bit, but then we found out that later. We set up the Hello World container, and we defined how do we store stuff in Git. I'm not going to go deeper into there, maybe in a blog post later or something, but we had a repo for Kubernetes deployments, a repo for our application deployments, and then kind of was the first contact with the development team what do they need in the cluster before we can start migrating. We identified that we need the networking, obviously, that goes both ways, and we can access outside world and databases that are still EC2 instances and are still just directly running. And then kind of monitoring was the biggest thing. We needed Prometheus, we needed Grafana and Greylog. Some of these things we had to migrate, and some of the things were just launched in parallel, like Greylog, that we had separate monitoring of what was in the old cluster, what was in the Kubernetes cluster and in the old on the old machines. And we had like some sort of continuous delivery working, that we built stuff, uploaded to ECR, and then it got stuff happened through Argo. I'm not like it just happens, hopefully, and it continues to do that. And then was the time to start with the first service. At first, we created a chart where all the services, like all of the dependencies, are interlinked, and decided to take the one with the fewest dependencies. Understood that it's going to be not really an actual problem, and being a dependency for other services is the problem, because the first service that goes into the Kubernetes now, all of the older ones need to point to it and communicate with it. So instead, what we had to choose was the service that has the least dependencies going in, and that has no side effects, because a bunch of our services were listening to some Kafka streams or Bull.js queues, or doing any other sort of magic that we wanted to avoid. So we chose the API that is serving the web app. It already had, like there was already a public-facing endpoint, and it was not doing any background work whatsoever, no queues, like I said, which like no risk of running multiple APIs, just like the web app wouldn't connect to this one. And like it was a very good starting point. We managed to get all of the containers running. We get all of the monitoring set up. Greylog, Prometheus was monitoring it. We could make HTTP requests to it and see what is failing and what isn't. And then we started migrating, and it turns out that, like, obviously, just because it looked fine on paper, didn't work out that well. A bunch of time was spent managing security groups in AWS, how stuff accesses Redis, and like a bunch of smaller, horrible UX things that we had to manually adjust in the UI. We also managed to, like, even though it looked very simple, and we created a separate hostname for the service, and we tried to migrate our web app to this new hostname, and that was a mistake, because it turned out that even though we changed all of the mentions in the code, AWS CDN was set up so that it caches some of the responses from the old API, and we missed it and caused the first downtime of the migration on the first service. The fix for that, and like the thing that we took from there was that from that point on, we migrated only using the same host names, and it was actually pretty convenient that when Kubernetes provisioned at DNS for a particular host name, it was not taking priority over stuff that was set up manually some time ago in AWS. It's just removing a CNAME record in AWS was enough to channel the traffic to the Kubernetes. So that was the first service was done. It was working. The website was served from there, and in turn, this service communicated with all the older infra and a bunch of services there. Next up were these smaller services that we had probably around like maybe 10 different ones. We are mostly running microservice architecture, with one service being the larger one, which is like the X monolith that we used to have from the older times. And in here, we hit first the situation when they were really, there was no way to understand what the service actually, the way that it was needed to be run, because it was just set up as one instance, and the other one was set up as one instance, but then it turned out that one service had to be run, it could have been run multiple replicas, and the other one was reading something from a particular database queue and only required to be one replica at all times. And because of that, when we were migrating things, we caused some duplicate events for our customers because we read from two places one event and then produced an actual event for our customer twice. A few other things, I'll go a little bit deeper on the next slide, but the way that previously we checked health was we had the whole setup. We were monitoring the health endpoints, and so when something was down and notified in Slack, that's it, some service is down. But nothing in the infra setup changed because the service was unhealthy. And that backfired for us a little bit down the road. And sometimes we didn't even know that service existed. We thought that if it's not mentioned in documentation and there is no repo in Git, that means that's it. And we shut down a server after migrating, and it turned out that there was some minor thing that was set up 3 years ago, never updated. It was not even added as a Git repo to our organization repo, and it broke down after we shut down the server. It's not really an artifact of the Kubernetes migration, but more having stuff undocumented and not added to Git backfires very easily. So after hitting some issues with our customers or noticing that something shouldn't have been run as multiple replicas, even rolling out an update to service when it was one replica already caused issues, because if we were rolling out a deployment update, then 2 pods would be running at the same time. So after fixing those things, there are kind of no learnings apart from after it's migrated. Now we definitely know the requirements for running it, and before we didn't. And I'm really glad that infrastructure as code offers you to document some of the things the way that they need to be run. In some cases, when the rollout was causing either that there are duplicate events created for the customer because 2 services were running at the same time. Alternatively, when we made it into a stateful set, it was first torn down and then recreated, but then we caused some issue with other service communicating with this one. And so we had to split some of the services into 2. One would be serving the API, and the other one would be a stateful set that is never run twice. So some application changes needed to happen for some of the services after the migration. Even though previously they also caused downtimes because we shut the service down and then brought it up, but it was not really noticed. And I'm gonna tell more about how we have cascading failures after migrating to Kube. Like I said previously, just having an unhealthy service was we were notified that it's happening, but it wasn't propagating anywhere the maximum because the traffic was still going to the service. So the example would be that we have some not really important service that is occasionally checking in some database stuff and updating some counters for our customers. It is needed to run our system as a whole, but it doesn't need to be running every second. And when it was going down, the moment that it goes up, it just catches up on some of the depth from the queue that was there. So previously, when that service was unhealthy, meant no issues for our customers. But our health check still checked connectivity to that service. And generally, we check connectivity to the dependencies as part of our health check. And after we migrated, we use health check as our liveness and readiness probe. And the problem now is that whenever a dependency of the service is gone, that service is also removed from traffic being served, being directed to it. And then anything that depended on that service is also failing the health check. And so when a minor service went down, we had cascading failures that go up to the whole system. When Kube decided nothing is healthy, I'm not gonna send traffic anywhere, and we went down because of the really minor issues. we had a fix for it, but we just started to implement it. In reality, like our reality was that after we made our situation a little bit more stable, like this kind of stopped happening as often. But it's still a risk and still sometimes happens. So for that, like the proper fix that we started would be to separate two health checks. One would be used as a liveness and startup, which includes the dependencies, and so everything is checked. But the constant readiness probe only checks like the stuff that is needed for the service to process incoming requests. And that way, kind of, there would be no cascading failures, at least. After we moved and like did a bunch of fixes for the smaller services, we moved to the larger ones. And larger ones offered the biggest benefit, because when we shut down like one server that was running multiple smaller services, we didn't really gain anything by migrating to Kubernetes on a larger scale. And the larger ones also caused bigger incidents. So we've had a bunch of issues, like when we started adding more nodes, more workers to our node groups, we hit the limit to access Redis because security group had to be explicitly defined every time. We didn't notice some of the things when database was not accessed because we didn't add some proper routing, and that wasn't automated in any way. We ran into issues with running out of IP addresses because we provisioned not large enough subnet in the first place and had to remigrate the whole cluster to another one. But I'm not going to go deeper, because for developers it was just kind of causing issues in the middle of the migration, but they were not solved by any developer input. But what had to be solved was a total configurational mess. We had, for example, one service was running on 8 different instances, and each one had different configuration because that service did a lot of stuff. Some instances were focused on doing a particular side of things. The other one was serving API for others. The third one was handling some particular queue because that queue was CPU intensive and it was limited to one particular server, so that kind of the throughput is limited by the CPU and not spreading across like all of the other servers, including the one that with the API. And I tried to simplify that whole thing by having kind of that configuration is more or less the same. And it backfired with the fact that once there were some requests or some things coming that caused higher CPU, then we overloaded the whole cluster with requests that didn't need to be processed that quickly. And then no requests were served except that particular load. And having kind of manually putting together configuration from different places was quite a struggle not to break anything. What we had to set up, because like for it to be working properly, was we had different kinds of deployments for every combination of the configuration that we needed to be done separately. So basically one container, one Docker image, has like 5 different modes that are operating right now. Each one of them has different configuration that is attached, that is mounted, and then like each service actually operates in each deployment that way operates in a quite different manner one to another, but it allows us to then configure it differently, set up resource requests and limits, amount of replica, and in monitoring you can also see when each mode is being is going down, or some particular part is working fine or not. Like right now they're all duplicated. Like every deployment is done like 5 times with like minor changes in the setup, and we would like to reduce repetition with templates. But right now it kind of it showed to be a bigger mess, and we still haven't done it. So a lot of duplication, but at least everything is separate and not impacting each other. We also have this thing that many servers used to have the setup when we would create different forks, like we have Node.js as our framework, and like all of the forks had to be not separated, but reduced to one and then made into pods. But like right now we're running a lot of overhead compared to what we were running before, because some parts of the service are not needed but loaded into the memory, and we have like one service that is constantly taking a gigabyte for no reason whatsoever. With the larger services, especially when we were hitting some issues with migrating them, kind of left us in the limbo state. And for development, that was really uncomfortable. You didn't know, well, sometimes you didn't know where the service is being served from. And the worst thing is sometimes it would be served from both from Kube and both from the old part, which was sure to be working correctly. And the new one, you're not exactly sure. We had two pipelines while we were migrating, and they uploaded to two different places, and when one pipeline was failing, the other one, maybe that wasn't the needed one, and developers weren't really actively fixing things when they didn't know that which part needed fixing. And it created a situation when developers were kind of waiting, like, okay, something is failing, but hopefully the infra people are just fixing it. And in reality, it was application errors that needed to be fixing, and the infra couldn't proceed because of that. And the fact also that we kept all the instances running, and then we were spending twice as much money for a particular service. Like the lesson there was to limit Limbo state as much as possible and try to have a very clear overview of what is migrated, to have documentation. Like we had a Notion page which says exactly what's the state, which one is served from where, so that any developer can easily take a look and understand that, okay, this is from the new one, I need to go to the new Greylog to find what's not working, and so on. And having a migration checklist really helped. Like checklists help for doctors, and they help during these things as well. Just when you have everything listed, when you need to shut down the old service, not forget to shut it down, not forget to remove the service from it, because occasionally we restarted an old server and the old service would come up because it was still present there. Migrations were key to this state. What we also had was a staging and pre-live environment in our old infra, and that, like you probably understood, that we really liked complex configuration setups, and this was no exception. Like every service was running not only had different configurations set up on different servers, there was also an extra configuration for staging and for pre-live, which had nothing to do with the actual one, was never really updated because it also required a manual update, and developers, when updating code, didn't keep it up to date, and it was kind of working. In the end, the fragility of the setup meant during migration we just couldn't migrate it. We basically left it as is, shut down, and right now we don't have staging or pre-live because we couldn't come up with a kind of adequate way of setting up the configuration in Kube so that it's not just a bunch of repetition that nobody can keep up. And so far we were kind of, we're lucky that we didn't need staging yet, and it wasn't actively used. We want to set up it with Helm or customized in some kind of way which can hold the complexity together, but it's not there, it's still not working, so we failed that part. And now kind of we migrated everything except for a couple of services that are related to email. And then I want to also to go over like some overall kind of, not just the journey, but the overall takeaways or things that worked out or didn't work out. So first I want to talk about some of the good practices that we wanted to implement and then understood that it didn't really work, at least for us. One of the things was resource limits. I was really keen to set up limits for every service that we had. looking at historical usage, or to be sure that nothing like a bug in the service is not overloading our workers and so on. But in the end, I gave up. Like, I set up everything manually everywhere, and I had resource requests, resource limits. At first I set up resource limits for CPU as well and for memory. And so resource limits for CPU meant that we were dropping actual incoming packets, and we didn't notice that until some time in. So we had to remove all of the CPU limitations, because kind of like as much as the service wanted the CPU, it needed to get, otherwise we were dropping stuff. But then it meant that, okay, that CPU can go to 120% and there's nothing to limit it. The memory limit was in a way better, but I based it on historical data on the usage of how much the service normally took, like added some buffer and so on. But the moment that some service took in a bunch of messages from the queue because there was like some delay somewhere and it needed to read not like 1,000 messages but 1,000,000 of messages, it hit the memory limit and was throttling and was killed. So neither CPU nor memory limit actually helped us yet. Right now we have like some adequate setup that are protected from Node.js bugs more than actual application bugs. So developers are still free to write code that is kind of overblowing everything, and limits don't help. Resource requests were used and are used because it helps with scheduling. But limits also, like I mentioned here, apart from all of the issues that we've hit, it's just so much manual work. Like every deployment, like we have 20 services, each has, some of them have many deployments, and it means like 30 different places where to manually set up whatever is needed, like historical memory, historical CPU data, and so on. Another thing was network policies. We wanted to limit communication between services. Only some services can talk to other ones, so that we kind of security, blah, blah, blah. Instead, in the end, not in the end, but very quickly we understood that the complexity for setting that up is just too messy. Developers really like to decide that now this service needs to talk to that other service and forget that now the policy needs to be updated, and we removed all networking policies right now altogether. We just set up some stuff in different namespaces, and we are ready to add policies in between namespaces, but nothing is set up right now to make it easier. Another security practice was we very neatly decided that like developers can manipulate pods. They can create deployments, but they can't edit deployments. They have access to config maps, but they don't have access to secrets. Everything seemed nominally very good. Like nobody can just go on and take a look at the database password. But it turned out that like it created more mess, because developers then asked me and Lauri to do any of the changes that needed to be done in the secrets. At the same time, they could always get into the pod, dump the environment, and see all of the values of the secrets that are injected in there. Like in Lens, they couldn't click and see the secret, but kind of it didn't really protect anyone from anything malicious. And we had to open editing for secrets for developers because of that. And now kind of people have ability to, when an API keys and secret is changing, they can do it themselves without us. Another thing that kind of, like if those are good practices that didn't work for us, I kind of think that we don't have enough good practices, or the idea of some of the things in Kube kind of made me confused. I like the idea of GitOps, really loved it after reading it. And we store as much as we can in Git, yeah. But then kind of the moment that you apply something with kubectl, you have no idea what is there. It's nowhere in Git. If that's a new thing, it's not even showing up in Argo as out of sync thing. you never know when somebody edited something that isn't edited in Git. And config map changes, like we wanted to set up that configuration of the services in config map, secrets are in secrets, and that's it. But then changing neither config map nor secret has any way of auditing. It's not showing up anywhere where developers can see when something was changed to understand what was the cause of an outage or when was the configuration happening. So the solution for that for us was to store as much as possible in repositories, like configuration, even though like 12-factor suggests that environment shouldn't be stored, we are storing really everything except secrets. We're storing in repositories, including the API key, and like that requires a secret, both a key and a secret. And we know that they need to be changed at the same time, but the fact that the key still requires a pull request means that we know when it was edited. And we almost stopped using config maps. Right now we're just having like a file mounted that was coming from the repo. Like this way we traded off ease of change in favor of tracing when the change was happening. I'm still looking for a tool, maybe actually, you know, something like that that would audit and allow to see when a change in secrets or configs was happening, like per namespace, because then I could map that stuff to Slack and let everybody would know that somebody changed something in a particular config map or in a particular secret. Tracing changes would be so much easier then. Like it's not all good, right? Like some of the kind of functionality that we've had before is now lost, and honestly, it was much easier to just SSH into the server, relaunch the node with the profile flag, and you have like the dump of what was happening in that particular server. Now there are so many more kind of hoops that you need to jump through when you set up, like you disable the probes, then you send a signal, then you kind of can attach to, but then you don't have the you have the read-only system in Kube, so the file isn't dumped there. Like it's quite messy. Previously, some of the things were definitely easier, including some of the debugging when you had like your service is running on two servers, you just SSH there, you get the console with the logs on your screen. When stuff gets killed, your container isn't relaunched, you're not disconnected from that pod, and so on. Like that stuff was easier than it is now. Like it's better to host in Kube stable apps than actually it was than unstable ones. Unstable ones are better hosted the old way, when just stuff dies and comes back or doesn't. If previously a bad pod, like a bad service would be killing a server or two, now we can kill the whole cluster because we distribute our pods that are like we have, I don't know, like 9 workers or something, and now if it's a service that has many pods, if they go nuts with the CPU or memory, then a bunch of stuff can die, including the way like the workers are handling out of memory situation when everything becomes super slow. Prometheus stops responding, and you don't know what exactly is causing it because the Prometheus is down, the one that you would be using to take a look which pod actually is misbehaving. Again, I mentioned it's still not good reason to limit CPU resources, and more like setting up some alerts when it goes over some level. And another thing that we haven't solved yet, and that is messy, is I can't really experiment with the environment. Like when I'm migrating, like changing Docker file or migrating something else with the node. Previously, I could do that on a particular server, and then rerun the service with the new data as part of figuring out whether it works or not. Now we have like the pull request, which is tested, but we aren't deploying the pull requests to any staging or some temporary place that we would be actually, the Docker would be downloaded, launched, and then we see whether it works or not. I want to make this work through probably some pre-life or like kind of a PR environment that hosts any PR that is happening, but it's not there yet. And some of the things we do right now are blind. Like I make a pull request, I hope that it works. I create a Docker image from there, deploy it as like one replica, and then see whether it worked or not. Definitely not how I want it to be done. But then there were obviously really important gains for the developer team, especially. So system did become more stable, even though because of the health check issues that we've had, where broken services didn't get traffic. It also means that when we're deploying something broken, it doesn't get traffic. And so the system became more stable just because of that, because we are still deploying stuff that is not working time to time, but now it's just a broken pod that we see in Argo as out of sync or a health issue otherwise. And there is kind of no pressure it's not urgent to just fix it right away. You can take a look what's there and fix it rather than revert it right away or run around with your head burning. Obviously, we have a bunch of benefits from running containers because previously we didn't have containers at all. Developers mentioned that it's easier to scale up, and now you don't have to. Previously, what did I do? I did something. Okay. If previously you if the server, we tried to optimize our load, obviously, even before. And if you had suddenly a more CPU intensive workload that you're deploying, you needed to provide an extra server for that, or be ready that your service will hit the limit. Right now, we can just up amount of pods or up amount of workers that we have, and you don't need to really think about it. You can roll out stuff that you want to be working quite easily, and then you optimize it in a separate on a separate cycle. You see that it works, and then you can optimize it at the pace that you like, or not optimize if you want to spend more money on the service. We also have better monitoring now. Previously, so much stuff was invisible, and now we see the health of stuff. We have very easy overview of all of the pods, their CPU usage, everything is in one place. We have Grafana dashboards, and we monitor Node.js lag and a bunch of things that we didn't do before. What I really like, because I did a lot of the migration myself, and the other people in the developer team did kind of a few. And when they have less experience with the deployment or some syntax, if previously nothing was stored, and now I can just point them to a Git commit that fixes it, and knowledge that is shared that way is way easier. And you can fix each other's things by a Git commit and then talking about it on a pull request. That's really amazing. And disaster recovery is way quicker because through Argo, reverting right now is very simple. And we also have different ways of reverting stuff, not just like previously. You usually had to revert the commit and only then it would work out. Now we can just deploy the previous container version that was definitely working, and that's way quicker. And obviously right now, developers are closer to DevOps because they can create deployments themselves. They can change configuration. And not only they can, but they're also responsible for creating deployments if they're creating a new service. And we don't need infra input whenever something needs to be changing, and creating microservices right now is cheaper, and it helps us to maintain this approach of like, this is something new, it means it's a new service, very easy to get it up and running. Previously, we always had a thought like, yeah, is it worth talking to infra about creating it? Now that kind of friction is gone altogether. And config changes, and now secret changes as well, don't require input from people with special permissions. It also means that when there's an API token changed by some service that we need, developers can just change it, and it will be seen in Git, and they don't need anybody's input in there. And the overall conclusion is that we spent a lot of time migrating, like several months spent migrating. And the disappointing part in there was for me that the infra cost didn't go down. I expected that since right now everything, different services are running on all together spread out using resource requests, that we will be saving some of the CPU money, but in the end we aren't, because while we are more efficient at running services, we are spending more money on the outbound connections. AWS is charging a lot for that. Previously, we were very carefully setting up which services have outbound connections. They have public IPs for those particular EC2 instances, and money and traffic was saved that way. And right now, it's not the case, and we are costing extra for that. But still, we have the highest uptime ever after migrating, and way less time to spend to add or change a new service, so it was definitely worth it, and quite a great experience for us. And thank you for listening. Thank you for sponsors. And do you have any questions?
What does Outfunnel actually do?
I should have put up a few slides about that. Outfunnel is a tool that connects CRM marketing tools, ad tools, and any other ways for you to understand your customers better, and puts that back into the CRM. So this is a tool that's helping sales and marketing people to know either their market or their customers or trial customers better. And right now we're building a tool that also uses the way that customers are using your product to analyze that and to be able to target the ones that need more attention to convert better. Like somebody does some particular thing, you see that they still are in trial, you can contact them in some way and talk to them and segment them based on the way that they've acted in your application. But mostly this is a tool that helps sales and marketing people get their shit together.
Six people on YouTube, but nobody asked any questions, so everything's clear.
Can you share, can you tell more about secrets management in the cloud environment, or tools you use slightly more?
Right now, actually, no tools apart from whatever Kube offers. So we have secrets that are set up manually or with kubectl. Like migration of secrets was that I took previously stuff that was in the old server as is, created a secret for that with kubectl in the needed namespace, and right now it's just there. And editing it is manual work. We thought about actually provisioning it differently, but right now I understood that it's not worth it. But you just go to Lens, you press a button, edit stuff, press save, secret is edited. But what I'm missing is proper grepping. I would like to be able to search everything for a mention of a particular key, or maybe even the value of a particular key. And there was some kube grep plugin, but I haven't really tried it yet properly, so not automated enough.
So, as I understood, you're still on AWS. You have this old setup, and but did you consider changing provider? Or did you compare variants?
We considered it, but the thing is that we still have database running outside of the cluster, and it's in AWS. And we also had we have some email-related things which we're sending emails, and we're sending them from particular servers with IP addresses with particular reputation. So we couldn't let that go either. And then understanding that we can't migrate away from AWS entirely, so we might as well set up like keep most of the things in AWS and set up EKS there. But we aren't really using, like we're using as little EKS special things as possible so that if we need to migrate, we can just migrate the cluster. But right now we decided that not worth the migration with the money that we might save there.
Why you consider other vendors? Is it because of money or lack of functionality?
One would be money. Like one of the reasons to migrate for us, one would be money, and the other one, I heard rumors that Google does it better. Because AWS setup for the cluster is way too messy. Like probably Lauri can say more about how messy it is, but there are things that are quite horrible with the subnets and terminology switches that they have, and it feels that a bunch of stuff that they did was to put Kubernetes cluster on top of their idea of how infra should be set up, which conflicted with some of the ideas with Kubernetes. And I've read that Google doesn't do it that bad, but I haven't tried.
So who made the decision to migrate?
To-
You said there were a lot of
Yeah.
questions, but I'm pretty sure there were people who were opposed to migrate. Like, let's keep everything the same.
Right, anyway.
The decision was kind of made before me. Like I arrived already at the moment when they decided that we definitely should do that, but unclear when, how is it worth it, and when's the moment that it will be worth it. The decision was based on inability to scale stuff and on kind of unpredictability of the uncontainerized application that we had running, and developers were too far separated. But the key thing for the business to approve that was scaling up and stability. The developers decided that it makes sense that containers in some shape or form is the way to go, but the end decision to migrate to Kubernetes was done by me after hiring an infrastructure person who was familiar with Kubernetes compared to ECS or anything, whatever other things there are. So it was more sort of kind of skill and expertise based decision, and I've had people who were saying to me that we should have gone for ECS because it's simpler. I don't know, time will tell. I don't trust ECS because it's a bunch of XMLs. I don't trust XML.
There's a question from YouTube, which it's a bit provocative question. Do you have an opinion on the systemd debate? I think he's referring to the systemd versus the older script-based initialization systems.
I don't have an opinion. I'm fine migrating from either of them. But then I should have repeated the question, no? Yeah. Systemd or not, whatever. Just go away from hosting stuff yourself.
Okay, so I think that's it.